So let's take a look at the problem landscape. Basically, we'll try to understand what kind of problems did the industry try to solve which eventually led to the rise of data science and machine learning. So in the previous slide, we learned that the root or the crux of data science actually came from business strategy and decision making. So while this happens, so when any organization is in the process of making a decision or implementing a business strategy, they actually try to solve a problem. So to understand the nature of the problems that actually evolved into data science, let's understand the crux of problem with more depth. So let's look at this representation over here. What we have done over here is we have tried to define problems using two dimensions. One is impact and one is frequency. A problem could actually have low or high impact, and the frequency could also be low and high. So based on these two dimensions, we can actually segregate the problems into these four quadrants, like low impact and low frequency, high frequency and low impact. Similarly, high impact, high frequency, and high impact, low frequency. So if you take a look at these problems in these four quadrants, we'll actually understand problems from a different angle. So let's understand this better. What kind of problems actually come over here? So low impact, low frequency. This is that segment which is actually not that important because the frequency of the problems is not so high and the impact is also so low. So it's okay to adjust with it. Organizations don't really bother to solve these problems. Then there are a couple of problems where the impact is not so high, it's low. And the frequency is so high that it becomes bottleneck. This is where we have the industry of IT solutions into the picture. So today, if you look into the IT solutions developed by major service companies, let's say Infosys, TCS, major outsourcing companies, we all focus in this area where you try to solve a problem where the impact is not very high, but the frequency is extremely high. So it actually makes sense to digitize a solution and permanently fix it. One common example over here would be a customer relationship portal, or let's say digitizing the inventory system. So let's say if a company has a digitized supply chain or an inventory management system, if it goes on for a day, the impact is not going to be terrible. It's going to be okay. But then once it's digitized, once the problem is solved, the frequency of this happening again and again, the frequency at which the problem comes again, inventory problems have to be updated, that's very high. This understanding gets better as we look into the other quadrants. So let's say what could be an example over here? Extremely high impact, but very low frequency. This could be as simple as, should I take the company public or not? Or should I sell the company? Or should I merge with this company? Or should I acquire this company? Should I sell my IP? These questions and these business decisions, the frequency is very low. It might happen actually once in a lifetime of a company, or probably once or twice in a year. So since the frequency is very low and the impact being extremely high, companies generally tend to spend more over here. Like it's okay if you spend a little high in this segment. So to solve these problems, like we have a couple of different industries called the consulting industry. So McKinsey, Booz Allen Hamilton, A.T. Kearney, Boston Consulting Group, all these consulting companies, they actually come into the picture when we have extremely high impact and low frequency problems. And then we have an altogether different game, like extremely high impact problems and extremely high frequency problems. A simple example would be the page ranking algorithm of Google. Like the impact is extremely huge and the frequency is also very, very high. Like you need to come up with an extremely robust and very powerful and more accurate version every day. Another simple example would be the pricing problem. Let's say for an e-commerce giant like Amazon or Flipkart in India, pricing of the products is something which is extremely sensitive and has an extremely huge impact. And the frequency is also very high. You have almost every day some new pricing technique coming into picture. The price changes for the product on a very frequent basis. So the idea behind dividing problems into these four quadrants are the way we approach these problems in these quadrants are actually different. So for example, let's take this bucket, low impact and low frequency. This could be something as trivial as an HR solution or a couple of people policies within the company where it's okay to delay it or it's okay to probably, my apologies, not necessarily HR problems are always low impact and low frequency, but then, these are those problems that the companies are generally not interested to solve. So let's ignore this bucket. Extremely high impact, extremely low frequency, it's okay to spend a little more, and companies like consulting come into the picture. Here, the approach to solve this problem is more heuristic driven, right? Similarly, if you take into account this segment, low impact, but the frequency is very high, like it may happen on a very high scale basis, you need to actually solve it very algorithmically. So as you move from low to high on the impact and low to high on frequency, here you tend to solve the problem more algorithmically, and here you tend to solve the problem more heuristically. The problem comes over here when you have extremely high impact and extremely high frequency. It's a combination of several things. So this is altogether a different ballgame. Let's ignore this for now. Let's focus on these two areas. So what happens is, in each of these quadrants, there are again two subsections, probably, yeah, we have a section where you have extremely high impact, extremely low frequency, but then again, there is a scope to divide them into two, where there is a small difference between this segment and this segment. The same happens over here. Now, coming back to the crux, let's come back to the first question. How is data science connected over here? So, as I mentioned, as we move from low to high impact, we move into a very heuristic approach. As we move from low to high frequency, we move into a very algorithmic approach. When these two converge together, we have a different set of interesting problems that we solve, and that is highlighted over here. It's extremely complex, it's extremely ambiguous, and it's extremely connected. You don't really have a structure to these problems. So what happens is generally a company starts solving somewhere in this section where it's moderately low impact and moderately low frequency. But the moment they try to solve this problem, they understand that, okay, we actually need to solve a problem which is connected to this and it is belonging to this domain. And similarly, something over here would be connected over here. Something over here would be connected over here. So the approach is very muddy. You'll have to do a lot of exploration to actually understand what is the structure of the problem. And that's when data comes into picture, because you have a lot of questions. These questions need answers, and then you have data-driven decision making. Now, this entire concept might sound very abstract. Let's take a very tangible example to understand how do problems actually fit in these different segments. So let's say someone like Amazon is trying to solve the problem of pricing. So they plan to solve the problem of pricing by implementing a technique which will actually update. And for simplicity, let's assume that we have just one product in the entire catalog. Let's say the product is mobile phones. So Apple launches a new iPhone is in the market. Amazon is actually implementing a pricing technique that will set up a new price point almost every day to have maximum sales. This is probably a very abstract problem, but then still let's take into account something that a company is trying to solve for the first time. Now, when they try to solve this problem, they'll actually understand, okay, before solving this problem, probably I'll need to actually have an entire digitized version of my catalog system, of my supply chain, of my inventory. So that's a problem which comes in this section. The impact is low, but the frequency is very high. And that is connected to a problem which comes in this segment. So they would actually go ahead, digitize the entire solution, get a solution in place where everything is connected to each other. We have one centralized database where all the inventory and management is done with a digital sense. All of that is done. And when one small problem is solved, they actually understand there's something more important that we need to solve over here. And that might be connected to a high impact, low frequency area. And this goes on. So what happens is this area that is a rectangle which touches all these four quadrants in a small way defines those set of interesting problems which lack a particular structure. You don't really have a standard protocol to solve these problems. It's a very exploratory approach. And these are the problems which actually led to the field of data science. So what happened is, you're trying to solve a problem, then you understand this problem is actually connected to another problem. It's extremely high impact, low frequency, it's an extremely ambiguous scenario. Now, to solve a problem in this segment, you don't have an approach. So you go a very exploratory way. And then in this process, you'll have a lot of questions. These questions again need a lot of answers. And in that process, you actually leverage data. Mostly it's a data-driven decision that you take. And this process gets complicated because the scale of the complexity increases as the impact increases for the problem. And in that process, we actually created an art, a new field emerged, that is data science. Machine learning is a smaller segment in this entire picture. We'll get into the depth of machine learning very soon. But connecting the previous slide to the problem landscape, we are trying to understand what kind of problems did the industry solve, which eventually led to the rise of this field, data science. So let's take into account the next section.